My name is Adamu Salahuddin. Welcome to our today's lecture on thermochemistry. From the word thermo, it means energy, heat chemistry. This is a branch of chemistry associated with the heat change accompanying chemical reaction. Every chemical reaction is associated with heat change. This might or might not be noticeable. Now let us look at the first law of thermodynamics, because there's no way you talk about thermodynamics, you will not first of all look at the laws that govern this branch of chemistry. One of it is known as the first law of thermodynamics. It states that energy can neither be created nor destroyed. It can be converted or transformed from one form to another. Let us look at some thermodynamic terms. A system. What is a system? This is the substance or mixture of substance involved in chemical and physical change of interest. And at the same time, let us look at what is referred to surrounding in thermodynamics. The surrounding is everything around that system's environment, that system that you are working on. Anything around it is referred to as the surrounding. And the universe. What is the universe? In thermodynamics, the universe is defined as the system plus the environment. The system of interest plus the environment. What is a thermodynamic state of a system? Thermodynamic state of a system is a set of conditions that completely specify all the properties of the system. The set conditions include the temperature, the composition, and physical states, whether the system in question is a gas, a solid, or liquid of each part of the system. The conditions that make up the state of a system and the variables that measure them are called state function. The condition that makes up the state of a system and the variable that measure them are called state function. The value of the state function depends only on the state of the system and not on the manner by which the system comes to be in that state. We have two types of thermal reactions. We have endothermic reactions. We have exothermic reaction. An endothermic, from the word endo, an endothermic reaction is one in which heat is absorbed. Endo means absorbing. Endo from the surrounding. It absorbs heat from the surrounding. An exothermic reaction is one in which heat is given out from out of the system to the surrounding. Generally, the moment you know whether a reaction is endothermic or a reaction is exothermic, you'll be able to determine the feasibility of such reaction, because for endothermic reaction that give out heat to the surrounding, increasing heat of that reaction, you are not helping that reaction because it doesn't like heat, and you are giving in. It gives out heat to the surrounding. Giving in heat to that reaction, you are not helping the reaction. But for exothermic reaction, in which heat is given out to the reaction, giving heat to the reaction will further make the reaction to be feasible. Look at we'll call this the energy profile. The energy profile of the reaction, we have that of the exothermic reaction, we have that of the endothermic reaction. You look at the activated complex, you look at the delta H, the change in entropy. This energy profile is that of water. The energy profile is that of water. The delta H and the delta E of the two are not the same. So there's a lot of difference between this profile, between the exothermic energy profile and the endothermic energy profile. If you look at, in this diagram, you look at the product, the PE for the product in exothermic reaction is lower than that of the endothermic reaction. Entropy. What is entropy? Entropy is the heat evolved or absorbed in a chemical reaction. It is generated by heat, and change in entropy is the sum of the entropy of the product minus the sum of the entropy of the reaction will give us the change, that is delta H of the reaction. The second law of thermodynamics states that in spontaneous changes, the universe tends towards a state of greater disorder, that is increase in entropy, greater disorder. And the third law of thermodynamics says that the entropy of a system of a pure perfect crystalline substance is 0 Kelvin. These are the pioneers of thermodynamics. His name is Henry Hess. He states what is known as Hess law. This law states that the total heat change, that is delta H, accompanying a chemical reaction is independent of the part taken. It's independent of the part taken. This is a very big law that help in determining that help scientists, most especially in thermodynamics, to determine energy change, that is delta H. Now, this is Born-Haber cycle. This is a special technique of applying Hess law to determine standard entropy change, which occurs when an ionic compound is formed. But in this case, the ionic compound formed in this case is sodium chloride, common sodium chloride. When you look at it, in this case, you can just go in directly from reacting the sodium ion with chlorine gas, the delta H formation to give you sodium chloride. Or rather, you can pass through a lot of stages. The sodium solid is sublime, that is used, and our delta H that is heat of sublimation is shown. It is changed from sodium to sodium gas. And thereafter, from that sodium gas, you remove an electron where that ionization energy comes in. Ionization energy is that energy required to remove the most loosely bounded electron. So by the time you remove the most loosely bounded electron by the ionization energy from the sodium atom, a sodium ion is formed. And you leave that there, and you come to the second side of the equation, a chlorine gas. You convert that chlorine gas using heat of atomization. An atom of chlorine is obtained from the chlorine molecule, and thereafter an ion of chlorine is formed as a result of electron affinity. That is, the chlorine is an electron is added to the chlorine to form an electron, a chloride ion. So the sodium ion and the chloride ion will react to form a sodium chloride. If you look at the various steps, at the same time, irrespective of the steps you follow, you still arrive at the same entropy of formation. These are one of the applications of Hess law. Entropy change. What is entropy? Entropy is delta S, change in entropy. In this case, we consider isothermal expansion of an N molecule of ideal gas from state 1 to state 2, from state 1 to state 2. And this is our first law of thermodynamics, is represented as dq is equals to dE plus dW. dq is equals to dW when delta E is equals to 0. And the change in entropy, that is delta S, is change in heat Q divided by temperature. So these are very useful laws which can help in solving most of thermodynamic problems. We sincerely thank you for listening, and we think In our subsequent lecture, we might take time to do more justice to this course, thermodynamics. But however, we want to appeal to you that you should try as much as possible to subscribe to our channel for more of this lecture. Thanks for listening.